In this lesson, we're going to learn how to work with the compound interest formula. So we previously looked at how we can calculate compound interest by hand, but we can use the formula as a shortcut. So here's what it looks like. It's an exponential equation because we can see the exponent is a variable. The A stands for the value of whatever sum of money that we're talking about is at the end of the time period. The principal is the original amount of money that we're talking about, either the original amount that was invested or the original amount that was borrowed, and A is the final amount, so the final amount that we owe or the final amount that we've earned. Our I stands for the interest rate. It's per compounding period. We're going to talk about what that means in a little bit. And N is the number of compounding periods or the time. So let's start off with an example just to understand how this formula works. So it says George decided to take a night school course at a local university and borrows $1,200 from the bank to pay for the course. The bank charges him at an interest rate of 5% per A. That means per annum. That's another way of saying per year. Compounded annually. Now this, we don't know what this means yet. We're going to talk about that in a little bit. And he plans to pay back the money in 4 years. So we see the word compounded here. Banks charge interest, or financial institutions charge interest compounded. So compounded interest, not simple interest. So as soon as we see the word compounded, we know we're dealing with this formula right here. So the first step is I'm going to actually write out all of the letters, and we're going to see which of these variables we know and which of them we have to find. So we have A equals P equals I equals N equals. So let's figure out what we're given, number by number. Let's start off with this 1,200. What does this 1,200 represent? It says that this is how much he borrowed. So we don't know how much he's owed or how much he owes at the end. So this must be the initial amount, and our initial amount is P. So our P is 1,200. What we don't know is how much he's going to owe in the end. It even asks us here, how much money will George owe after 4 years? So we don't know the ending amount. So I'm going to put a question mark here. I stands for the interest rate. Do we know the interest rate? Yes, it's 5%. Now, whatever interest rate we put in here has to be converted to a percent. It has to be converted to a percent. So I'm going to just write a reminder that we're dividing by 100. Okay, so we're going to take our interest rate, which is 5%, and we're going to divide it by 100. And as a decimal, our 5% is 0.05. This says it's compounded annually. That means that interest is charged once a year. We're going to talk about compounding periods next, but all we need to know right now is that we get charged 5% per year. N stands for the number of compounding periods. Another way to think of this is that it's the number of times that interest is charged. So if interest is charged annually, that's what that means. We're going to talk about this again. That means how many times are they going to charge us interest in four years? And the answer is 4 times. So we are going to get charged for interest 4 times once a year. That's what this means. Interest rate is 5% per year. So if it's 4 years that he's going to owe this money, then he's going to be charged 4 times. Once you have all of your letters filled in, now it's the easy part. We're just going to write out the formula and then fill in the numbers. So once you fill it in, this is what it should look like. A, we don't know. We don't know the final amount that he's going to owe. Equals, we know our principal amount. Bracket 1 plus, instead of I, we have 0.05. And then instead of our exponent, it's 4. So I can quickly, just applying BEDMAS, add together what's in our brackets, and then just throw that into the calculator. Okay, so it's going to be 1,458.61. So what did we just find? What we found is A, and A is the value at the end of the term, either what we owe or what we have earned. So that means that When George borrowed $1,200 4 years ago, in the end, this is how much he owes. So the next question says, how much interest is he actually going to pay for this loan? So we know that interest is the cost of borrowing money. So unless we're just borrowing from our family or our friends, anytime that we borrow money from a financial institution, they make us pay for it. And that's what interest is. It's just a fee that we have to pay. So how much total did George have to pay to borrow this $1,200? Well, if he has to pay back $1,458.61 and he only borrowed $1,200, we can find out how much interest he actually paid. So how much are they actually charging him? By just taking what he owes and subtracting just what he borrowed. So what's left over? We have $258.61. So that is the amount of interest. That's the total interest charge that he has to pay. What if we work on a slightly different problem? So this says Janiyah takes out a loan from the same bank as George. So they get the exact same interest rate. It's 5% per year. That's what /A, it stands for per annum. But she pays back $2,000 at the end of the loan's term, which is 5 years. So she borrows some other amount of money, and she's going to pay back $2,000 in the end. And she borrowed this money for 5 years. The question is now, how much did she originally borrow? So we know that it's going to be compounded per year. It doesn't say that, but the word compounding was in the last example. It says it's the exact same bank. So again, this is compound interest, which means that we're going to use that formula. So I'm just going to write out all the letters again. A equals P equals I equals N equals. And we're going to fill out what we know. So let's start with, I'm just going to go in order. The first number that I see is this interest rate here, 5%. So we know that that goes with I. So we know that 5% as a decimal, okay, we did this already. If you just need a reminder, 5% as a decimal, we're going to divide it by 100% and we get 0.05. From the previous question, we know it's compounded annually. We're not quite sure what that means yet. We're going to talk about it, but right now we're just going to leave the interest rate just like this. Okay, the next number that we have here is $2,000. What does that $2,000 mean? So it says that she pays $2,000 back at the end of 5 years. So let's just go back to our equation here. She pays back $2,000 at the end. Is that originally what she borrowed? Or is that what she owes at the end? It's what she owes at the end. So this number here is whatever is happening at the end of the story. How much we are owed, how much we borrow, or how much we owe, or how much we have earned if it's an investment. And this P, think about this as the number at the beginning of the story. Originally, how much should we borrow, or how much should we invest? So this $2,000, this is at the end of the story. This means it's our A. She owes $2,000 at the end of the story. And it says she owes it at the end of 5 years. So this is how much she owed at the end, but how often was she charged interest? 5 years, and interest is charged per year, so that means she was charged 5 times for interest. So the number that we don't know is how much she borrowed originally. We don't know the beginning of the story. We don't know how much she owed at the beginning. So now that we have all our letters, we're just going to start off with our formula, and we're going to fill it in. And this time, we know our A. Our A is 2,000 equals, we don't know the P. We don't know the original amount, so we're going to leave it P. Bracket 1 plus, we know our interest rate. It's 0.05. And then we know the number of times we're charged interest. It's 5. So what to do here? Now we're looking for a number. We got to get rid of all this stuff. Before we do, let's just apply BEDMAS and let's just deal with those brackets. So we have $2,000 is equal to P 1.05 to the power of 5. So how do I get P by itself? Well, I got to move this entire thing. And how can I get rid of times this entire thing? Just divide by that whole thing. I'm going to get rid of times 0.5 to the power of 5 by dividing by 1.05 to the power of 5. Okay, so now this entire thing here, this is going to cancel out. 1.05 to the power of 5 divided by 1.05 to the power of 5, gone. So we have P equals, and then we're going to throw this whole thing into the calculator. Here we go. It's going to be $1,567.05. So does this number make sense? Were we supposed to get a bigger number or a smaller number? Well, if this is what she owes, that means that interest is included there. So what she originally borrowed must be less than $2,000, and our answer is less than $2,000. So this number must be what she originally borrowed. To figure out how much interest she was charged, we can just take what she originally borrowed, subtract it from what she's owed, and it will tell us, the difference will tell us the total interest. So this number just represents how much she originally borrowed. So let's talk about compounding periods. There was this term in this last example, said compounded annually, that I said, we don't really know what that means. Let's talk about it later. So let's talk about that now. So compounding just means when is interest calculated. So interest can be calculated or charged to us annually. That means once per year. We know that. And our interest rate just remains the same. So if interest is charged to us annually, once more, it just means that it's charged to us once per year. Our interest rate is just whatever interest rate is quoted, because it's always quoted per year. And the value of n is just the number of years. So, for example, the two examples that we just did were compounded annually, and we can see that our n value was just equal to the number of years, so 5 and 5. Same with on the other page. It was 4 years, and our n value was just 4, so they just matched. So when interest is charged to us by a bank or credit card or some sort of financial institution, when interest is charged to us annually, it just, our value of n is just the number of years that we're holding that investment or borrowing that amount of money. But what if it was compounded semi-annually? That means that interest is charged to us multiple times a year. Semi-annually means that it's charged to us 2 times per year. Well then, the interest that they charge to us, so semi-annually means basically every 6 months. So every 6 months we get charged interest. So we're not going to get charged interest by the yearly rate. We're going to take that yearly rate and divide it by 2. That's confusing to you. You'll figure out the pattern very quickly once we do some examples. So just sort of memorizing, we're going to talk about why this works. We're going to take the number of years and multiply them by 2. We'll explain how this works later. Let's deal with quarterly. How many times per year do you think is quarterly? It means 4 times. So interest can be charged to us 4 times per year. We would take our interest rate and we would divide it by 4. And we would take the number of years and we would multiply them by 4. That's how many times we're going to be charged interest. So let's just go through this chart. We're going to explain more what it means in the next examples. But monthly, how many times per year would that be? 12 times. We'd be charged 12 times per year. We would take our interest rate and divide it by 12. And we would take the number of years and multiply it by 12 to figure out how many months we're going to be charged for. Weekly is 52 times a year. Following the pattern, I take my interest rate and divide it by 52. And the number of years get multiplied by 52 to find the number of weeks. And then daily, there's approximately 365 days in a year. That changes on leap years. So 3 out of 4 years, there's 365 days in a year. Our interest rate is going to get divided by 365, and the number of years is going to get multiplied by 365 typically. Okay, now that we have that chart done, maybe you're like, I don't really understand that chart. You're going to understand it more as we do these examples. So this question is asking us to calculate the amount owed or earned at the end of the term. So we're looking for A for each of these examples here. So I'm just going to write out A, P, I, N because I already see the word compounded. I see it right here. So as soon as we know that this interest is compounded, we're going to use the shortcut, which is that formula. So we know that for each of these questions, we're looking for what's owed or earned at the end. So in this case, it's owed because we're borrowing money. So $300 is borrowed at 9% per annum. That means 9% per year, compounded daily for 2 years. Daily for 2 years. I'm going to change this question just so that it makes a little bit more sense. I'm going to change it from daily to semi-annually. So just copy that down. There's nothing wrong with daily, but I want to make sure that we can all understand what's going on with the interest rate. It's going to be easier to understand if it's semi-annually. Okay, so let's deal with this number, this first number right here. This 300. What is that 300? That's the original amount that was borrowed. So we're going to put that as our p-value. What's our interest rate? Our interest rate is 9%. We know we need to change that to a decimal. So we're dividing it by 100 and we get 0.09. So here's the important part here. This says that it's compounded, interest is compounded semi-annually. We change it from daily. If it's compounded semi-annually, that means in English that interest is charged to us 2 times per year. So let's make this make sense. If we're being charged 9% interest per year, would it be fair if we're charged 9% 2 times in the year? Then we would be charged 18%. That's not fair. So what we do is we take this interest rate, if we're charged multiple times per year, and we divide it by the number of times per year. We're going to take that and divide it by 2. And we're going to get 0.045. So this is the interest rate that we're actually going to be charged each period. Again, 9% is for the whole year. So, but if we get charged twice a year, it's not fair if we get charged 9% both times. So we're going to divide the number by 2. This is what we're going to be charged each point. So we can use our chart as sort of a cheat sheet. So for semi-annually, we're just going to take our interest rate divided by 2. If you understand what's going on, you don't need to memorize that chart, but you can use that chart anytime you want. Okay, so N. N stands for how many times are we going to get charged interest? Well, we're holding on to this thing for 2 years, so we're borrowing it for 2 years, but we're going to get charged 2 times per year. So I'm going to take that 2 and then multiply it by 2. We're going to get charged 4 times per year. So that's why we're multiplying by 2. If you need to, if you need to, you can just use the chart for semi-annually. We're not going to take the number of years and multiply it by 2. So if you want to just use the chart, sort of memorize it, that's fine. But now we understand what's going on. So now that that's done, we're going to just throw it into our equation and solve. So fill it in and solve. We're going to come back to the video once that's done. So if you're back, you should just have our final solution, filling in our A, P, I, and N. So this is the answer that you should have, $357.76. So we just threw in our P, our I value is not our original one, we had to divide it by 2, and our N value is 4. And here's our final answer. So for this one, try this one on your own. We see the word compounded, so we know that we're going to use the compound interest formula. So we have A equals P equals I equals and N equals. So I'm going to read this to you. Try this one on your own and then check back in the video to make sure you have the right answer. $7,000 is invested at 3.5% per year, compounded quarterly for 5 years. So use the table above and come up with your new values. If you're back at the video now, you're checking your answer. You should have tried this one on your own. All right, did you get these values? A, we're looking for A. We mentioned at the beginning of the question was always asking for the final amount. That means that this is our original amount that we invested. So that's our P. Our I, did you get this as our final answer? Please take as many decimal places as you can because it will give us the most exact answer. So we have 3.5% divided by 100. Then we're compounding quarterly. That means we're being charged interest 4 times a year. So it's not fair if we get charged 3.5% 4 times, but because that's quoted as what we're supposed to be charged for the whole year. So we're going to take that guy and divide it by 4. Or you could just use that table above. It will tell you for quarterly, take the interest rate divided by 4. And N is 20. How many times are we being charged interest? Well, if we're being charged 4 times a year for 5 years, we're multiplying by 4. So these are the numbers that we should have come up with. So after putting all of our numbers into our formula, 7,000 for P, 0.00875 for our N value is 20, we should get this as our final amount. A quick assessment, does this number make sense? We invested $7,000 in some sort of investment that earns us this amount of interest per year. So our final number that we're owed or that we've earned at the end of the 5 years should be larger. And it is. It's not absurdly larger, but it's larger. So this is our final answer. So if the compounding periods is really messing you up and you don't really understand what's going on, we're going to keep practicing it, but remember you can always just use this table. Okay, let's work on our last example here. It says Akua wanted to have $3,500 in a bank account 4 years from now for school. She can invest her money and earn 9% interest compounded monthly. Okay, so just as an FYI, this is a really unrealistic goal for us if we're starting to invest our money. So to earn 9% anywhere is like incredible. So she found this crazy investment where she could earn 9% per year. Amazing. So the question is, oh, by the way, it's compounded monthly. How much money must she save now to reach her goal? So I see the word compounded, so immediately I'm thinking compound interest formula. So I'm going to write out my letters first, and then we'll figure it out from there. Let's work this out number by number. So it says that she wants to have $3,500 in her bank account 4 years from now. 4 years from now. This amount is what we want in the end. It's the future value. It's our ending value. This is our original amount. This guy here, what is that? That's what she wants in the end of the story. That's what she wants in the end. So in the end, at the end of the story, she wants to have $3,500. And she wants it 4 years from now, which means she's going to be investing her money for 4 years. So we know where that 4 goes. It goes where our N is. She can invest her money and earn 9% per year interest, so 9% per year. So we know that that 9% goes here. And I'm going to immediately change it into a decimal. So I'm going to make it 0.09. And then it says compounded monthly. What does that mean? Compounded monthly means that interest is going to be charged to us every month. In this case, it's a benefit to us because that means we're going to earn interest every single month. So instead of earning interest just one time a year, we're going to earn interest 12 times per year. So we can use our chart to figure out what to do with the interest rate, or NN, or we could just figure this out logically. This is the interest that we are going to earn in a whole year. So how about per month? Well, we would just divide that by 12. So that would give us an actual interest rate of 0.0075. How about our N? Our N stands for the number of times we are going to earn or have to pay interest. In this case, we're earning interest. So if we're holding this investment for 4 years and we're getting interest every month, then I'm just going to take my N and times it by 12. And that's what our chart also shows. So we're going to earn interest 48 times. So now that we have all of our variables, now it's just the easy part. We're going to just put it all together into our formula. So let's do this one last time. A equals P1 plus I to the power of N. In this case, we're given our final value. She wants $3,500. Our P value, the original amount, we don't know. And I'm just going to add these together really quickly. So 1 plus our interest rate is just going to be 1 point our interest rate. So I'm just going to add that together really quickly. If that confuses you, just do it in 2 separate steps. And then all to the power of our N value is 48. So how do I get P by itself? We did an example like this already. I have to get rid of this entire thing here. So how do you get rid of times this thing? We're just going to divide by that thing. So we're going to divide by 1.0075 to the power of 48, and we're going to do it on both sides. We know that these 2 things are going to cancel out. They're going to equal 1. And into the calculator, We're going to put 3,500 divided by bracket 1.0075 to the power of 48. And the answer I got was $2,445.15. So after you come to your answer, we got to make sure, is this reasonable? First of all, should this answer be smaller or larger than 3,500? Akua wants 3,500 in her bank account in the end of 4 years. So the original amount she should put in, should it be more than that or less than that? It should be less because she's going to be earning interest in this investment. So this makes sense that this number is less. So this is how much she has to save now in order to have $3,500 in the future. How much money did she make from this investment? She originally put in this much. In the end, she got $3,500. So how much money did she make? It's not a question that was asked in this particular one, but can we figure that out? Can't we just take the total amount of money she earned minus the amount of money she originally invested? And how much interest did she actually gain? She gained $1,054.85. So that's how much she earned in interest. That was not asked in this question, but it's important that we're able to find that.